All right. Hey, everyone. Thanks for showing up to this ICCC beginner talk. Today, we're going to talk about one of the most ubiquitous categories in CTFs, which is web. So just to get started, here's a quick summary of the web. So you have this, and then you also have this. Don't forget this, and this, and this, and this. Yeah, did y'all get that? Cool, awesome. All right, moving on. So next we're going to talk about binary exploitation. Just kidding. So essentially when we're talking about web for CTFs, this is sort of the mental model that we're working with. We're not going to worry about packets. We're not really going to worry about DNS lookup most of the time. We're just going to think about we're talking to a server and the server is talking back to us. So essentially, we can just think of the entire internet as just a really elaborate message passing system. And these messages that we pass, how do I get rid of? Oh, these messages that we pass to other computers and have passed back to us are called packets. So let's go through an example of a communication between you and a website when you try to visit that website. So essentially, there are three pieces of the puzzle here. On the very left, we have your computer, which is the client. And your computer communicates with the server, which is here in the middle, through HTTP or HTTPS. HTTPS is basically the same as HTTP, except it's encrypted. And the server will respond back to you with an HTTP response. So this is how you communicate with the server. And the server on your behalf will also communicate with a database, most likely. And it will do so using database queries, which are written in SQL, structured query language. And the database will respond through this SQL communication tunnel. Is this clear to everyone? All right. So I know this looks a little bit scary, but we're just going to go through this real quick. Suppose you navigate to example.com. Then your browser sees that you typed in example.com and press enter. So it creates a GET request, which is one of the different types of requests. Mostly you're going to be dealing with GET and POST requests. And a GET request basically means, I know you have this file and I'd like to request it. So your browser will then send this GET request over to the example.com server. And the example.com server will respond with this HTTP response that contains the contents of index.html. So this is an HTML document, and it contains links to other documents, for example, scripts/index.js. So this is a JavaScript file. And the moment our browser sees the script tag, it's going to then generate another GET request to request scripts/index.js to the example.com server. And of course, the server is going to respond the exact same way, except this time, instead of responding with an HTML file, it responds with a JavaScript file. So this is what JavaScript kind of looks like. Here we're defining a function, and essentially this is code that is now running inside the browser, but in a mostly secure way. So let's say now the user, they click a button or they press enter on a form or something, then submit form ends up running. Then the user's browser will then run this fetch command, which creates a POST request to /login with the username and password embedded. So now we have a POST request to log in with the body username equals Jigu and password equals Hunter2. So this is why it's super important to use HTTPS, because if you don't use HTTPS, all of this communication you have with the server is sent over plain text. So if you log into a website using only HTTP, anyone that is on the way from your computer to the website can steal your password very easily. Anyway, if we zoom out a little bit, then the server is going to take the password and username you gave it and then send it over to the underlying database. And the database is going to respond telling the server whether or not it recognizes that username and password combo. So since it responded with this record, the server now knows that the user exists and also knows its email address. So it can log the user in. And in order to log the user in, it creates this HTTP request with a special header. A header is just a piece of metadata attached to the HTTP response called set cookie. And this will set a cookie. In this case, the cookie is called token. And it's going to set this to this weirdly encoded string right here. And essentially, this is the server giving the client a ticket. And the client, every single time it wants to make a request, will then hand this ticket back to the server so the server can authenticate the user. So now the server knows who the client is because it can check the cookie. Do we have any questions about this little scenario right here? All right. So most of the vulnerabilities we're going to be focusing on today are a result of placing too much trust in the client. So remember that in the web attack model, the client is completely controlled by the attacker. So the attacker has control over all JavaScripts run by the client and has control over all the HTML. When the server responds with an HTML file, the attacker doesn't necessarily have to show that HTML file directly. And if the server sends over a JavaScript file, the attacker doesn't necessarily even have to run it, or they can run a slightly modified version of that JavaScript, or even a significantly modified version. In general, if the attacker can fake a request to the server and the server trusts that request, then we're kind of in trouble. So we have a little bit of an interactive component here. So I mentioned that the server sets a cookie on the client side so that the client can use it as a token to hand back to the server every time it would like to perform something that only users are allowed to do. But since the cookie belongs to us, we can just change it to whatever we want. So this would be if the server gave us a ticket and we went back and scribbled over our name on the ticket and wrote someone else's name on there, and then handed that ticket back to the server, we can trick the server into thinking we're someone else. So a secure server would do a signature on the cookie to make sure it's not fake. So in order to achieve this, usually Jwt tokens are used. So Jwt tokens look kind of like this. It's a bunch of base 64 strings with dots in between them. And one thing to watch out with Jwt tokens is make sure that they're not using the none algorithm, because the none algorithm means the Jwt token is actually not signed. So you can modify the Jwt token however you want. Yeah. JSON web tokens. So if you were to put this Jwt token through a base 64 decoder, you would actually get back some JSON. And of course, you can create your own JSON and convert it to base 64 and generate your own Jwt tokens, but they would have to be signed. Okay, all right. So I'm gonna give you all a minute to log on to this website and try to mess with the cookies. So you can, if you're on Chrome, you can mess with the cookies using inspect element, application storage cookies. All right, there's a good question here. If the cookie is sufficiently large, wouldn't the probability of falsifying someone else's be low? Are there better ways to do that? So the cookie, most of the time, especially with JWT tokens, the cookie is structured. So essentially that means the cookie itself doesn't provide any integrity. So if you steal someone else's cookie somehow using some methods that we'll talk about later, you can just copy their cookie and use their cookie, and the server will think you're them. In addition, JWT tokens in particular are just base64 JSON. So if you were to just decode that JSON and figure out a way to bypass the signature, then you could change the data to whatever you'd like. So for example, if there were a field in there called username, you could just modify the username field.
So to make you understand this correctly, so instead of passing like bar1 equals hello or something, you're doing like all that through like a hash or something to be clicking it. And it's typically like the C4 hash.
Can you clarify your question a bit?
So it's just kind of okay, so like the hash is generated.
Mm-hmm.
It's like a C4 algorithm.
Base64.
Basically.
Yeah.
And then like invert it afterwards.
Base64 is not an encryption algorithm. It is just a way to encode data in a way that's convenient. So this JWT token looks like a bunch of garbage, but it might as well have been sent in plain text.
You could show them what a JWT looks like.
Okay, so we can, exit. Yeah, so there's this really handy website, jwt.io. So here's a JWT token. Right here, we have the header, which basically says what the JWT is using. So in this case, algorithm is HS256, which is, I believe, stands for HMAC SHA 256, something like that. So this is a type of signature scheme, and also says the type is JWT. And then here we have the payload. The payload is going to be just JSON data. So in this case, we have this subfield, this name field, and this IAT field. If we were to just mess with the name field, then we would end up with a slightly different JWT token. And this signature right here, this is pretty hard to fake unless we know the server's private key, which typically only the server knows its private key. But if we took, for example, are we allowed to set the algorithm to none? No, I guess it won't even allow us to do that. But if you leaked the server's secret somehow, like if the secret was something dumb, then we could fake our own JWT tokens and the server would believe our JWT tokens.
Okay, so
yeah, and there's also no confidentiality. So if you were to intercept this cookie and you just took the middle part out and put it in a base64 decoder, you would instantly get everything that's in the token. All right. So has anyone logged in successfully as this other user? Yeah. All right. Is anyone still working on this? Are the online people still working on this? The online people still here? Okay, if you're on mobile, you might have some trouble getting through the exercise, but I could go over the. I'll go over the solutions. Does anyone want a few more minutes to work on this before I reveal the solution? Anyone online? Anyone in person? All right, guys. I'm going to go over the solution now. So we're going to go on to this website, and we're currently logged in as this user. So if we right-click on this website and click Inspect, we open the element inspector. Then we can go into Application and this cookies place, and we find this very convenient cookie called logged in user with the value of our username. So if we simply double-click on this, we can change our username to whatever we want. So as soon as we do that, we get access to everything this user has access to. All right. Do you have any questions about this? Yeah. In this case, there's no signature because we're not using a Jwt token. We're just using a plain old cookie, which is honestly not worse than using just a Jwt token with no signature. A Jwt token with the none algorithm is a little harder for the attacker, but not really. Yeah. Do you have any more questions about this? Yeah. Oh, once you change the cookie, you have to refresh the page. If you refresh the page, you get it? Okay, yeah. So the cookies are only sent when you talk to the server. If you just change the cookies, the website's just gonna stay the same until you refresh, and then the server gets your new cookies. All right, so this one's, so here's another example of a challenge that shows up quite frequently in CTFs. So essentially when you have client-side sanitation, whenever you hear the word client-side, that means bypassable. So essentially, sometimes a site will sanitize or check a value basically entirely on the client side. For example, the username must not contain HTML characters, or the username must not be empty. And tricking the server into accepting an invalid value can sometimes break. You can chain this with other exploits to gain control over the website and stuff like that. So here is a mini challenge to register as admin. And a few ideas to do this are, number one, you can mess with the JavaScript in the page, which in this case just means redefine a function. There's a function in this particular challenge that if you overwrite it, gives you very easy access, very easy bypass of the sanitization. Firefox also has an edit and resend feature. If you open the networking tab and you see a request going out, there's also, when you see a request, you can copy as curl and then modify it a little bit and copy it into the terminal and run it there. So these are all a little bit involved for first-time web people, but essentially you're trying to first create a good request and then modify that good request to into a bad request. So I'm going to give you all a few minutes to work on this. All right, has anyone successfully completed the challenge yet? Come on, Ethan. Did you not finish it? Aren't you the president of this club? Oh, you have a chat message. In Chrome, how do you edit the JavaScript file? So you actually can't edit the JavaScript file because Chrome's the way they show you the JavaScript file is it just shows you directly what the server sent you. But what you can do is you can take that function definition that is in the JavaScript file and copy it into the console. And then once you press enter, the new definition of the function will replace the old definition. Does that answer your question? Mm-hmm.
When you use the Firefox edit consent, it automatically changes the
Oh, okay, very cool. I don't think they did it a few years ago, which is when I made these slides. All right, has anyone gotten the flag yet? Would anyone like a few more minutes? Would anyone on Zoom like a few more minutes? All right, so I'm just going to go over the solutions now. So how do I, okay. So now I'm just going to open this in Chrome. And we see this make a new account page. It says your username can't be admin. So the first thing we're going to try is make our username admin. And it shows this pop-up window. Now the pop-up window is a pretty big hint because pop-up windows are generated by JavaScript. So let's take a look at the JavaScript. This is the entire website. It doesn't look like there's a lot. But here we have some JavaScript that's embedded straight into the website. And it looks like it checks if the forms, the register forms username's value is equal to admin. And if so, it alerts your username cannot be admin and returns false. So it looks like this return false stuff is causing our request to not go through. So we can simply copy this function over and modify it so that it always returns true. Now we have redefined this function within the context of this particular page. If we were to refresh the page, then we would go back to the original function. But if we run this again, now we're back to the evil function again. So we're gonna log in again with admin, and we're gonna create a password. And now we have admin privileges. Okay. Does anyone have any questions about that particular exploit? Yeah. I looked at the source first, and then I copied this JavaScript and pasted it into the console. This is a function declaration. In JavaScript, if you declare a function multiple times, the one that runs afterwards is the one that actually ends up happening. Right? Any more questions about this one? All right. Yeah. Any web-based languages? Well, WebAssembly doesn't let you do that. Most of the time, you won't be dealing with WebAssembly anyway. But it doesn't actually matter because all of this code is being run on the client side anyway. So the attacker has 100% control over what's run on their own machine, right? The actual vulnerability here is not the fact that JavaScript lets you redefine functions. It's the fact that all of this stuff is happening on the client side in the first place. That's a great question. And I'm about to show you another way to bypass this, which is more, which is usually more, more convenient. So first of all, I'm gonna clear this networking tab. So this network tab is really useful. It shows you all of the network requests that are going through this website. So if we create a username, password, then we end up with this register.php request right here, which is a post request. And the post request body is a form data with username Jwt. Okay. So one thing that's really helpful is we can copy this as curl. And curl is a Linux command that lets you make web requests really easily. So if we copy that curl, this looks kind of scary, but essentially it's just taking all the stuff we were sending before and putting them into a format that curl can accept. So if we change this username equal to admin, then basically what the server was going to send to our browser is now being sent to our console. So this is curl pretending to be Chrome. In fact, you can see that it's pretending to be, it's pretending right here that it's Chrome because of all of these headers that are being sent over. So the server can't actually tell the difference between a request that's being sent through the browser and a request that's being sent through curl using this copy as curl functionality. Does this make sense to everyone? We just took this perfectly fine kosher request and copied it as curl, then pasted it into the terminal and modified it. So it's no longer good. All right, yep. Yeah, so we right click on this and we copy as curl. And there are a bunch of other ways you can copy these, but curl is generally the most helpful. And then the last way to get in, which in my opinion is like this is my favorite way to do it, is Firefox has this really nice feature called edit and resend. So if we open Firefox and it looks like I have to clear my cookies because it's remembering me from last time. Okay, let's just, I'm not sure why it's, oh, right, because this is the register page, my bad. Okay. So we also go into the networking tab here and we create a username and password. And inside this networking tab, we see this register.php request. And we can click this button called edit and resend. And now this request body, we can just modify it to say username equals admin. And, it looks like content didn't update. I'm not sure if I'm using a bad version of Firefox or something. But if I then grab length of this request, it's length 14. So we can go back to our networking tab and change the content length to 14. And we can send this request over. And if we then look at the response from this request, we got the flag. Does anyone have any more questions about this? All right, so that's 3 different ways to bypass client-side sanitation. Some of them will work some of the time. And then this next one is a little bit more advanced. So this is cross-site scripting, which is one of the most ubiquitous bugs out there. I think this is like #1 on the OWASP top 10 or something, or what was it? It's definitely in the top 10. Oh, it's been demoted to #3 because everyone's using React now, which is kind of lame. But essentially in this scenario, whenever the website shows any sort of user-generated content, that's a possible ingress point for cross-site scripting. So, for example, let's say we have a user that posts on a forum that says, "Hello, I am not a hacker." And you'll notice right here, this looks like HTML. And in this case, it just shows, just turns this hello and makes it italicized, which seems kind of harmless, except when you realize that HTML can actually contain JavaScript in it using the script tag. So if the attacker creates a script tag here and runs some JavaScript, and that JavaScript happens to make a request, guess what? The JavaScript will then send those cookies along with that request, the same way we saw the legitimate client send the cookies earlier. And that's done automatically. So if I were to fetch something like delete account, this makes a request to the endpoint delete account as the user that is viewing this page. So basically anyone that sees this message, their browser will now automatically run this JavaScript, which tells the server to delete their account. And the server will be okay with it because the server will just check the cookies and the cookies are all okay, right? And then another kind of helpful thing to do would be to fetch to some other website that's controlled by the attacker. And I don't know if y'all realize this yet, but basically anyone can create a website. But if we have, for example, evil.com controlled by the attacker, and we just take document.cookies and attach this to the end of here, then the attacker all of a sudden has stolen our cookies. And they don't even have to do everything right here on the spot because they've already stolen our cookies and they can do whatever they want as our user. So essentially a few ways that this attack can manifest itself. Cookies can get leaked using that evil.com exploit. You can create a cross-site scripting worm. For example, if inside your JavaScript, you made a request that modifies your profile to also contain this cross-site scripting, exploit, then everyone who sees your profile will now have this exploit on their profile, and everyone who sees their profile will also have it on their profile. So then you can very quickly exponentially spread this cross-site scripting attack to basically every user on this website. Did it happen to MySpace? I believe it. I'd believe it. But yeah. So here's kind of a little fun exercise where I'm actually going to pretend to be an admin and you guys are going to try to hack my browser. Is it gonna be admin? Oh, frick, what's the password again? I changed the password to something secure. Oh, wait. Yeah, I know. It's in my Bitwarden. Here we go. That's not the right password, I guess. Well, it's not showing my password anyway. I'm gonna try Safari because I already logged in through this. Well, you can log in as admin because I know the password. I guess I don't know the password, but I have the password somewhere. All right, I'm gonna stop sharing for a second so I can look up the password. Now I have to use another password to log into my server so I can get the password. I just need to go into this thing and mess with the permissions a bit. All right, let's see. All right, looks like Palo Alto Networks, NGFW, and AYA have successfully become admins. Congratulations. Okay, I'm not seeing any more requests go through. Does anyone want me to critique their payload? Why doesn't the alert show an alert on my screen? Because I overwrote the alert function. Okay, and just as a reminder, the syntax to create a script tag that makes a GET request is this right here. So you open a script tag, you call fet, parentheses, quotation marks, and then the URL you want them to visit, and finally end script tag. And if you guys send over the payload, I can take a look at it and give some tips. So someone requested localhost.com:5050/name. I'm not sure if that helps you become admin, but cool. Okay, so for this particular one, I believe okay, why is Palo Alto Networks NGFW trying to mess with my website? Okay. Whoever's doing this JSON placeholder.typicode.com post one thing, I believe if you just replace that URL with the promote, looks like someone got it, with the promote link, then your payload should work. All right, is hello there someone on Zoom or someone in person? All right. All right, does anyone want to work on this for a few more minutes, or do you guys want me to go over the solution? Who wants a few more minutes? Okay, so this is gonna be the last challenge of the day, but let's see. Let's go to the website that you're trying to hack. And this says first create a username. And the username is Jwt. And you're able to leave a ticket. And as soon as I leave a ticket, it shows up. Oops, it shows up right here under my username. And it's saying if I send this link to an admin and they click on it, then I will become the admin. So we can use that payload, which is begin script tag, fetch, open parentheses, open quote, the link. And this is a cross-site scripting exploit. And once we submit this and the admin loads our request, we become an admin. All right, do we have any questions about this exploit? Yeah. Yeah, so we could click this link right here, but it won't let us do anything because we're not authorized as an admin, right? The thing is we want an admin to click on this link. But because we are able to perform cross-site scripting, we're able to do anything we want as an admin. And the way we do that is by writing this JavaScript. Yeah. And this JavaScript, this is just one line of JavaScript code that calls fetch, which is a built-in function in browsers. Yeah. All right, do we have any more questions about cross-site scripting? All right. All right, cool. So here are a few more common beginner CTF problems. Whenever you see a beginner's web challenge, you should always check these out first. robots.txt, .git, jwt.io, that website I showed you earlier. There's also SQL injection and a bunch of other stuff in the OWASP top 10. These are all worth looking up whenever you come across a beginner level web challenge. And do we have any more questions about web in CTFs? Oh. Have I seen web challenges with exposed htaccess files? I'd say those are pretty rare, mostly because the default for Nginx and Apache is to not let you expose them. So it'd be kind of convoluted to set up that challenge. And honestly, it would feel a little bit contrived. What kinds of information can the document leak? Like the cookies example was given, but would there be other kinds of information? In this case, we're not really leaking any information. This information is really just given to us by the server. What we're doing is we're modifying that information and handing it back to the server in a modified way. So you can mess with the cookies. If you add cross-site scripting, you can steal someone else's cookies. In the fetch command for document.cookies. Oh, well, most of the time you only care about the cookies because once you have the cookies, you're sort of winning. There are also situations in which sometimes cross-site scripting is used to perform fingerprinting. So if a hacker wants to keep tabs on a group of people that are accessing a website, they can use a cross-site scripting vulnerability to phone home to the hacker's website. For example, they could tell what IP address they're coming from, what browser they're using, and all of that. And that that information comprises a fingerprint. And this can be used by certain nation states to spy on people by taking over by taking over websites. Does that answer your question? I would bet a significant amount of money that this has happened before. It's just that they usually blame it on someone else. Is there a browser header to restrict the origins that can be accessed by a fetch request on a page? Yes, that is called the, is it the CORS header? I'm not exactly sure, but there are a lot of headers that you can mess with. But most of the time in a CTF setting, these are not going to be used. And in fact, on day-to-day websites, especially really badly coded ones, they usually don't make use of these browser headers. There's also CSP, content security policy headers, which basically says, on this page, we're going to allow this JavaScript to run, but we're not going to allow any other type of JavaScript to run. So that will basically thwart any cross-site scripting attacks, because this relies on the attacker being able to add extra JavaScript to your page. Okay, yeah, I don't think CORS is what I'm thinking of. CSP is more applicable to this particular instance. All right, do you have any more questions? CSP needs inline enabled if you want WASM. Okay. They were actually talking about this in the WASM specification group. They were talking about adding another CSP specification that's WASM specific. So you can allow WASM, but not allow inline. It's a bit weird. I think it was the Chrome people that were trying to do that. All right, any more questions? Last call for questions from in-person people, Zoom people. What's the difference between SQL injection and cross-site scripting? So they're quite different, actually. A cross-site scripting attack will run code on the client of someone else, on someone else's client. A SQL injection will run code on the database. So we haven't gone over SQL injection, but that will be a topic for Web 2. All right, so if we don't have any more questions, I'm good with ending the recording here.